Hello, let's start recording. What we have here today, how to create contour plots and 3D surface plots in Python with Matplotlib. First we have to start as usually to import Matplotlib and pyplot as PLT, and then we will import NumPy as NP with less verbose, and let's start. Contour plots. What are contour plots? Basically, what we want is to have something like this, an X, a Y, and then we want the Z value on these contours, okay? And this will give us for kind of the intensity here on this surface, okay? So let's start. First, you see this code right here, because before we really start with the contour plots, we have to generate the data. The contour plots, they need a 2D grid. A mesh or grid is needed whenever we want to visualize data as a surface or contour plot. So usually until now we have single lines, and now in PLT point plot, but now we need a 2D grid. And for that we first start to generate a 1D array for the X and Y coordinates, like this. We use the linspace function to generate X between -3 and 3 and 50 points. We do this for the X and the Y, and then we want to create the mesh, and we use this function right here, okay, which creates the mesh for each pair of X's and Y, and we save it. Then we want to define a third coordinate, the Z, which is will function like the height or the intensity for each X and Y location, and we will define it as the sine of X multiplied by the cosine of Y, and this will be our Z, which is what the Z array is what we will actually visualize on the contour plot. And now, having this, we can start with the contour plot. So the contour plot will be PLT from the Matplotlib pyplot. We'll use the function counter for X, Y, and Z. And now we have the CMap viridis, which is the color. We'll see on the next graphic how more about the CMap, but let's keep it right here. Then we add the title, contour plot, which is we have right here. And then, since without this was not very easy to explain, to understand, we added another a color bar for the Z value, okay, and with this color bar of the contour plot, we set the label since this will be for the Z value, and then we do show. And so on this value we can see, according to the color, that here in this screen we have higher values, and for the darker contours we have lower values, negative values, and this screen here it's 0, for example. And this is the contour plots. Let's go now for the 3D plots. We generated with the same data, the contour plots, with using exactly the same data, we can generate this 3D plot. We have the X, the Y, and the Z, which is this kind of surface, the intensity of this surface, okay, like the height of the mountain. And what we need first, we we import. This is some legacy. The newer versions of Matplotlib already have this, but we have to import here because not every version has. We import from this. We import the 3D, how to do 3D plotting from Matplotlib. Uh, we create first a new figure using the function figure. We define the size, okay, the x for the width and the height for the height. Then we come here and we have a figure subplot at the position 1, row 1, column 1, uh, and first subplot. Okay, this is what it means, 1, 1, 1. And we add the 3D projection, which means that we have a 3D axis. And then we have the plot surface. We have the x, the y, and the intensity, which should be defined by the z. And now we choose the color, okay? These colors are given by what is called the Viridi's palette, okay? Which gives us dark purple for lower values and this yellow and for the higher values. And between one and the other we have this change, different kind of green. What can we add also the X labels, the labels for the X, Y and Z. We set the title and we show the plot, and this is what we have right here. So two things, we see that this Z right here doesn't appear all, and to this we decrease a little bit the size of the plot, okay, for 0.9, and it should work. Okay, if you ever have this problem, you can represent the figure, the size of the figure as large, and then you decrease what is inside the figure. Okay, what is the 3D box inside of the figure, and then everything appears. This is a nice trick and not easy to find out how to solve. Then the CMap, what can you do? How can you work with these colors? If you want to reverse the color, you just add here underscore R, reverse, okay, and then you have the different colors. You inverted the color, or you can give other colors. There are two that we see more. Cool, warm, we already see. You guess what it is? This is warm, higher values, lower values, cool. We have the blue. Okay, probably the ones that you see most often in, for example, scientific publications are the turbo. Okay, this color is or even for publicity of different kinds of softwares are these. The turbo, and it's quite nice. Okay, this is it. We can now practice here a little bit. Okay, I already imported Matplotlib and NumPy, and let's now practice a little bit. So let's first start to generate the data between -3, 3, and we generate just 50. We can use this. Don't forget this source. So we generate the same thing for the Y. Okay. Not so fast. X, Y, NP, mesh, grid, X, Y to generate the grid, and then the Z as the intensity. Always using NumPy, the scene function. Okay. And then multiply the cosine. Okay. I think it's all to generate the data. Okay, that's alright. Now let's go for the plot. As we see, it's not difficult to generate a counter plot. Counter plot. PLT. Counter. We don't need a CMap. Here. PLT title. Okay. Label. We can try. We just put. Really, we don't need. C bar. We need this to understand the plot. Was really important. I always like this. If not, nobody understands anything. And now the C bar. C bar. Z value for us to understand what is there. Z value. PLT show. Quite simply, let's see if this is okay. And it's alright, okay. Z value. We don't need underscore here. And we have the counter plot. Quite simply. Okay. You have everything here. Okay, let's go to the next one. The 3D plot, also not difficult to generate. PLT figure fixed size. I want 8 here. I already optimized this, so don't need to do it right now. Fig add subplot. Let's use this right here. 111 projection 3D exactly. And for this axis, we'll plot surface X. I don't want. We generate the turbo. We don't need this. We generate the turbo. We already have everything. Let's check what we have. X label. X. Ready. Okay. X set box aspect none for the first, but we just alter the zoom. Right. Exactly. And now a title. We can leave a 3D plot. And we show, and okay, simple instructions. It's a comma right here, okay? And there we have it work. Simple instructions. You have all of them here right now. I'll leave a few seconds for you to check. And now we have the 3D plot with the Z inside and the turbo colors. So that's it for today for how to create counter and 3D surface plots in Python with Matplotlib. Thank you very much.